Objective 2 has to do with phase changes, and we're going to be dealing with water, though if we had more information we could deal with any substance that changes phase, and they all do. We're going to calculate enthalpy or heat changes that occur, and we're going to use this graph to help us plot where we're headed. The first one says how much heat. Once again, it's going to be in kilojoules, so we will have to pay attention to that. When 35 grams of liquid water at 40 degrees Celsius is converted to steam at 130 degrees Celsius. Lots and lots of information after that, but the important things we need to know to get started are what is the temperature that we're starting at and what is the temperature that we're ending, because that will help us determine how many steps we have to take. We're starting at 40. That would be somewhere 0 to 100 is 40. Liquid water is at 40. We're going to end at steam at 130. So what this shows me is that I have to calculate all the heat needed to go from here, that's one step, to boil the water, that's another step, and then to change temp to get up to 130. It's a 3-step problem. Once I know that it's a 3-step problem based on where I have to go on this graph, almost like a map, then I'm going to start setting or framing this problem. Each time I'm using 35 grams of water. So if I have a 3-step problem and it's 30 and I have 35 grams, I'm going to have to do 3 calculations for 35 grams of water. The first step is going to go from 40 to 100. That's warming up a liquid. That's an MC delta T because there is a change in temperature. That's the formula for warming it up, and that's a liquid. The next step is going to be to boil or vaporize. I'll just write boil. It's a different type of calculation. We'll need a heat of vaporization. Finally, we need to warm up the steam to a hotter temperature, and if we're changing its temp, it's an MC delta T problem. The first part then, we are changing liquid water from 40. Well, we're heating it up, and the hottest we can make liquid water is 100 before it starts to change. So, since we're dealing with joules, we're going to need the MC delta T, but we already wrote that. So, the heat is mass times the specific heat. The specific heat of liquid water is, find it, 4.184. 184 joules per gram degree Kelvin. The change in temp. Now this can be confusing for some people. I don't go to this and subtract 130 from 40. That's the entire change of temp. But this segment only deals with the change of temp from 40 to 100. That's when it's going to boil. 100 minus 40 is 60 degrees Celsius. One more thing to check is grams and grams will cross out. Degrees Kelvin and Celsius, because they're the same size, they can cross out. But that's going to be in joules, and I need it to be in kilojoules. So one last step. Want over given. I want kilojoules. I was given joules. 1 kilojoule is 1,000 joules. If I just build that into there, I will get my answer in kilojoules. 35 times 4.184 times 60 divided by 1,000, 8.78, or rounding up 8.79 kilojoules. Moving on to the next one where the water boils. The boil doesn't have a change in temperature. It's simply you keep adding heat, it stays at the same temperature until it turns into gas, and then it can go up. So there's no change in temperature. Boiling just requires the heat of vaporization. Heat of vaporization for water is 40.7 kilojoules per mole. Another curveball. If I were to try to cross off things to see that I was converting to kilojoules, I have grams on top and moles on the bottom. So they really don't cross out. So really what I need to include is this idea that I need to figure out how many grams of water or how many moles of water I have. I have 35 grams. What I want to know is moles. I know the relationship between 1 mole of anything and how many grams it is. I simply use the chart to look it up. It's a molar mass. H2O is 2 hydrogens and an oxygen. That's 16 plus 2, 18 grams. Now grams and grams cross out. Moles and moles cross out. And when I calculate this, 35 times 40.7 divided by 18, this will actually be in kilojoules, 79.13 kilojoules. A much bigger number to evaporate something, to make these molecules jump out of the container, takes a lot of energy. Finally, the last part. Now I have steam, and that steam is at 100 degrees, but now I need to keep heating it until it gets to 130. M times C times delta T. The mass is 35 grams. This time the specific heat is for steam or gaseous water, which is 1.84 joules per gram degree Kelvin or Celsius. My change in temp, once again, I start at 100 because that's when it actually boiled. My change in temp goes to 130, so that's a change of 30 degrees Celsius. Once again, also, if I was to cross things out, I would only have joules, so I need that one more step of want over given to convert joules to kilojoules. The relationship of 1 kilojoule is 1,000 joules. That way, the joules will cross out and leave me kilojoules. 35 times 1.84 times 30 divided by, because it's on the bottom, 1,000. 1.93 kilojoules. The last step is simply to add up all three of these numbers, 1.93 plus 79.13 plus 8.79 to get 89.85 kilojoules of energy. Flipping this over, this one will be done very similar to what we just did, but we have to read. Let's see, we're going to change 8.5 grams of water at 125 degrees Celsius. We're going to cool it to ice at negative 30. 125 is way up here. Negative 30 would be way down here. 1, 2, 3, 4, 5 steps. How many grams do I have? 8.5. So I'm going to write that this is a 5-step problem. 8.5 grams, 8.5 grams, 8.5 grams, 8.5 grams, 8.5 grams. We have a change in temp, a condense, a change in temp, a freeze, and a change in temp. All the change in temps are MC delta T. The first one, the third one, and the fifth one are MC delta T's. The other ones are condense, that'll need a heat of vaporization, and freeze, that'll require a heat of fusion. All of this information is here as well as on my test taking tool. Things we're going to have to pay attention to is the fact that we're going to want kilojoules, and yet they're going to give us kilojoules and joules, so we have a step there. Also that when we're doing heat of fusion or vaporization, they give us molar heat, so we're going to have to figure that out, but it's for water, which is 18 grams. So the first one, MC delta T, 8.5 grams, times specific heat of liquid, no, we are at steam. How do I know we're at steam? If we start at 125, we're up here in steam land. This one will be liquid. This one down here will be ice land. 8.5 times specific heat of steam. This one doesn't have the information written into the problem. So what do I need to do? Just consult my test taking tool. Specific heat of solid, liquid, gas, 1.84 joules per gram degree Celsius. 1.84 joules per gram degree Celsius the change of temp, we need to simply go from 125 to 100 before a phase change occurs. 125 to 100, that's a change of temp of 25 degrees Celsius. The next step, that would allow grams and grams in degrees Celsius and degrees Celsius. The next step is to turn it into kilojoules. What I want to know is kilojoules. What I was given is joules, want over given, and 1 kilojoule is 1,000 joules. That one is set up. I'm going to keep going, set them up, and then I can crunch the numbers later. Next one's a condensed one. That requires a heat of vaporization or fusion. In this case, heat of vaporization because it's happening at 100 degrees Celsius. What is the heat of vaporization for water? 40.7 kilojoules per mole. But how many moles do we have? Well, we'll just build that into the problem. 1 mole of water is 18 grams of water. That one's set up. The next one's the next MC delta T. This one is to get from 100 to 0, which is liquid water. The specific heat of liquid water in joules is 4.184 joules per gram degree Kelvin or Celsius. Remember that we're going to have to change it back into kilojoules, so 1 kilojoule over 1,000 joules. And that one is set up. Now we have the freezing point. That's called the heat of fusion for water. The heat of fusion is 6.01 kilojoules per mole. 8.5 grams times 6.01 kilojoules per mole. This was grams, this says moles, so we have to do the 1 over 18 thing again. 1 mole of water is 18 grams of water, so that it will be in kilojoules, and then moles will cross off and grams will cross off. Finally, the last MC delta T. We are changing. Ultimately, we're trying to get to negative 30, but we were right here at 0. 0 to negative 30 is a change of 30. 8.5 grams times, we need a specific heat. It's an MC delta T, so the C is specific heat. Specific heat of ice, 2.09. 2.09 joules per gram degree Kelvin. Change in temp from 0 to negative 30 is a change of 30 degrees Celsius. And this would be in joules again. So once again, we're going to do the times 1,000. Times 1 over 1,000. 1 kilojoule over 1,000 joules. I'm seeing something. I'm seeing this one stretches out far and this one stretches out far. This was also an MC delta T. I wonder if I missed a step. If I really try to cross off grams and grams and joules, I got a degrees Kelvin out there. I must have forgot a step. I forgot the delta T, or the change in temperature step for this section. So how do I go about fixing that? I go back to look at the middle portion. Remember, this is a 5-step or a problem. 1, 2, 3, 4, 5. It's the third step, 1, 2, 3, that it seems like I goofed up on. I forgot to put the change in temperature. We're going from 100 down to 0. That's a change of 100 degrees Celsius. Remember, it seems confusing, but we can cross off degrees Kelvin and degrees Celsius. We're talking about the difference between those degrees on the thermometer is exactly the same. So the difference would be the same, even though degrees Celsius and Kelvin are not the same. Now they are all set up. Could crunch the numbers, add all 5 of those together, and you would get an answer in kilojoules.